A very good morning to all of you. Our subject microprocessors and microcontrollers. The prerequisite of our subject is computer organization and architecture. Our course objective, internal organization of 8086 microprocessor and 8051 microcontroller. We will discuss the concept of interfacing microprocessors with the external devices. Also, we will study assembly language programming. Module 1 covers the evolution of microprocessor, 8086 microprocessor architecture and signals, memory organization, minimum mode of operation, maximum mode of operation, its timing diagram, and then comparison of 8086 with the 8088. So before moving to the evolution of microprocessor, we will discuss what is a microprocessor. A microprocessor is a controlling unit of a microcomputer fabricated on a small chip capable of performing ALU, arithmetic logic unit operations, and communicating with the other devices connected to it. The computer's central processing unit CPU built on a single integrated circuit, that is IC, is called microprocessor. We can say that it's a programmable, multi-purpose, clock-driven, register-based electronic device. Microprocessor consists of ALU, register array, and a control unit. In this block diagram, we can see a microprocessor having ALU, control unit, register array. This ALU that performs all the arithmetic and logic operations on the data received from the memory or an input device. And the register array that consists of registers identified by letters like B, C, D, E, H, L and accumulator. Then the control unit that controls the flow of data and instructions within the computer. Now we can see how a microprocessor works. The microprocessor follows a sequence of operations like fetch, decode and then execute. Initially, the instructions are stored in the memory in a sequential order. The microprocessor fetches these instructions from the memory and then decodes it. After decoding, it executes these instructions until a stop instruction is reached. Later, it sends the result in binary to the output port. Between these operations, the register stores this temporary data. So, the temporary data that will be stored in this register. And the ALU that performs all the arithmetic and logical operations, that means computational functions. So we can say that this microprocessor that reads binary instruction from the storage device called memory and accept binary data as input and process these data according to the instructions from the memory and provides the result as output. Then coming to the evolution of microprocessor. The microprocessors are classified according to their specification, application, architecture. Here we are discussing the evolution of microprocessors based on the generation or size of microprocessor. These are 4-bit microprocessors, 8-bit microprocessor, 16-bit microprocessor, 32-bit microprocessor and 64-bit microprocessor. First, we can discuss 4-bit microprocessor. In the case of 4-bit microprocessor, this is considered as a first generation. The first microprocessor was introduced in 1971 by Intel Corporation. It was named Intel 4004. It was a 4-bit microprocessor. It was a single chip. It could perform simple arithmetic operations like addition and subtraction and logical operations like Boolean and Boolean OR. It had a control unit capable of performing control functions like fetching an instruction from the memory, decoding it, and generate control pulses to execute it. In the case of this 4-bit microprocessor, it can represent only signed numbers in the range -8 to +7, which is very small range. So it was not really of practical use of arithmetic calculations. Then Intel introduced an enhanced version of 4004, that is 4040, in 1974. There are other 4-bit processors are also available. Then coming to the second generation, that is 8-bit microprocessors. It was introduced in 1973 by Intel. It was Intel 8008. It was the first 8-bit microprocessor which could perform arithmetic and logic operations on 8-bit boards. In 8008, the data with the 8 bits as the word size, it could represent signed numbers in the range -128 to +127. This is also not a good enough range of performing arithmetic calculations. The enhanced version, that is 8080, that was introduced in 1974. It was also 8-bit microprocessor, but it was 10 times faster than 8008. Then in 1976, Intel introduced 8085. That was also a 8-bit microprocessor, and it could access 64 kilobytes of memory. And its data bus is 8-bit and address bus is 16-bit. There are many limitations for this 8-bit microprocessors because of its less powerful instruction set, limited number of general purpose registers, and low memory addressing capability. So it provides a low speed operations. Then coming to the third generation, that is 16-bit microprocessor. In the family of 16-bit microprocessors, Intel's 8086 was the first one to be launched in 1978. So the introduction of this 16-bit microprocessor was a result of increasing demand of more powerful and high-speed computational resources. This 8086 microprocessor have say much more powerful instruction set along with the architecture development. So it provides a high-speed operation when compared to the 8-bit microprocessors. In the case of this 16-bit microprocessors, the operations are performed on 16-bit. With the 16-bit word size, it can represent the range of we can represent the numbers in the range -32,768 to +32,768, which is quite a decent range for performing the arithmetic operations. And in this case, in this third generation, the speed of processors were 4 times better than the second generation processors. There are many 16-bit processors are available. Motorola came out with a 68000 and Ceylon released Z8000. Then Intel also released 80286 in 1982. Its clock speed was 8 megahertz. Then coming to the fourth generation, that is 32-bit microprocessor. The most popular 32-bit microprocessor is Intel 80386. It can operate on 32-bit data. So its data bus is 32-bit and address bus is 32-bit. And it could address 4 gigabytes of memory. Then in the case of this fourth generation, with the 32-bit word size, it's possible to represent numbers in the range -2 times 10 to the power 9 to +2 times 10 to the power 9. So it can represent a large numbers range for performing arithmetic calculations. This processors are very popular as the CPU in computers for number of operations. Then Motorola came up with a 68020. It's a 32-bit processor. Then Intel released 80486. It's an advanced version of 80386. Then Intel released 80586. It is by the name Pentium processor. It is extremely fast in performing arithmetic calculations and executing instructions. In Pentium, there are different Pentium 2, Pentium Pro, Pentium 2, Pentium 3, Pentium 4 are available. They are 32-bit processors, but they are considered as 5th generation. And coming to the 5th generation, after 80856, Intel came out with the processors like Pentium processors, that is Pentium Pro, which allows multiple CPUs in a single system to achieve multiprocessing. In the case of 32-bit microprocessor, Intel introduced Intel Core 2 in 2006. It was a 16-bit processor. All the operations are performed in 64 bits. So from 1995 to until now, this generation has been bringing out high performance and high speed processors that make use of 64-bit processors. Other include 64-bit processors are Celeron, Dual-Mnet, Quad, octa-core processors. That's all about the evolution of microprocessors. Then we can discuss some of the terms which are used in microprocessor. Instruction set. It is a set of instructions that the microprocessor can understand. So we already discussed. This microprocessor fetch instructions from the memory. Then the bandwidth. Bandwidth is the number of bits processed in a single instruction. And the clock speed, it determines the number of operations per second the processor can perform. So it is expressed in megahertz or gigahertz. It's also called clock rate. And next is word length. We already discussed this word length. Depending upon the width of the internal data bus, registers, ALU, etc. An 8-bit microprocessor can process 8-bit data at a time. The word length ranges from 4 bits to 64 bits depending upon the type of microprocessors. We have discussed this in the evolution of microprocessors. Then data types. The microprocessors has multiple data types formats like binary, BCD, ASCII, signed and unsigned numbers. Thank you.